So today we are going to continue our previous lecture. Uh, the first part of that about the security authentication mechanism that was done. And then we decided the rest of the part we will be continuing in the next upcoming week, which is today. So today we will going to continue from there and complete that one as well. And probably if time allows, we will go for the next topic as well. So the last time we discussed about the outlines, and especially we completed the part which is for the authentication. The computing concepts, hardware virtualization, and web development technologies. These are the things that what we are going to focus today. And then we will be discussing about the different cloud service models as well. And we will try that we may cover at least one of the model, which is the SaaS today at least. So a quick recap for the previous one that we have done about the authentication. And in that particular part, we discuss about what is the authentication, how it is further derived or divided into the identification and verification. And then we discuss the different sorts and different types of the authentication as well. So we try to compare about the authentication.
帮我们
Yeah. And also we try to see what is the authorization and where it when it starts, how it is linked with the authentication. And then with the authorization, we also discuss after that the conventional methods for the authentication. And then we also discuss the few of the advanced methods for the authentication as well. What do you mean by the conventional methods? Conventional methods, it means that those are the procedures or the methods which are normally being used, and the other which are supposed to be means deployed or implemented with the specifically for the cloud. And in those advanced authentication methods, if you remember, we discussed that there are the three different methods, and two of them are mainly used, including the multi-factor authentication and the risk-based authentication mechanism as well. So multi-factor authentication, it means the two-way authentication or three-way authentication mechanism, or for example, we can use the OTP concept, and these are all of the proper methods what we are using for the authentication, and mainly we are applying those mechanisms for the cloud. And we discussed the importance of the cloud, because the cloud, it contain not only the data for the one user or for the one organization, but that it contains the data for almost means several organizations. So that's why we have to be means careful about handling its security mechanisms. So in multi-factor authentication, then the further recap about the risk-based authentication. So if you remember that we discussed about the risk-based authentication, is that we counted that how the people are going to access our system, and whatever the way they are adopting, either multi-factor authentication, either conventional authentication, or either the federated authentication mechanism. That was the third one, if you remember. So whatever the mechanism is there, but we try to use the risk-based authentication, which is the normally available and in being in used for so many things. So in that particular way, what we are doing in the risk-based authentication mechanism, we try to calculate, and we see that how many times, suppose user is trying to get the login first time, so how much will be the risk of the security there, and if suppose it is going to attempt for the 2 times or 3 times, the number of the times, then we decided to the sum factor. And based on that factor, we try to stop the access of the user either for the some time or either for the long time, and we can ask to the user that either they have to verify their account by providing these secondary questions or second mechanisms. So the question is that you need to understand when we are just trying to freeze their account or stop their authentication for few minutes. Why we are stopping for the few minutes only, for 5 minutes only? The reason is that when we are stopping for the few minutes, the particular reason is that we are trying to avoid the DDoS attacks, because mostly the DDoS attacks are being happen through machines. Okay, mainly the machines are there, bots are there. Means very less that the human manually or physically doing the DDoS attack, but they are very sophisticated and some smart type of attacks are there. So in that particular case, if suppose any bot or any machine is attempting to have the access for that particular account, so we'll see that account is freeze, and then they will switch or change their direction to the some other site. So that is the concept behind that, that you need to understand that why we are freezing the account for 5 minutes. And if suppose after 5 minutes again the user is coming with the same issues, then probably we freeze the account and we allow them to go to reset the password or reset the password with the help of their secondary questions and the other questions. That is the further sort of the mechanism where we can try to check their authentication more properly. That is all about the recap that what we discussed last time. Then we discussed in the multi-factor that we are considering the 3 major things, that something you know, something you have, and something you are. Means who you are. It means that something which belongs to your personality, like your biometric identity or your speech recognition or your iris recognition or whatever, that is particular belongs to the user. And something you have, it means one-time token or OTP or password or something, whatever it is, that what you have. And something you know, that is the password. So these all are the things which are actually confidential and private. So this is how we are handling in the multi-factor authentication. And risk-based authentication, as we discussed, that how we are doing that, then we either save the account after a few of the attempts after calculating the risk like that. And then we discuss about the IDP. The IDP is the identity provider, or it is in short, we call it IDP for the authentication mechanism. And finally, the last point about the recap, that is about another mechanism of the authentication, which is known as the fidelity. If you remember, that was what we also discussed. So these are the public IDPs and other things that what we discussed in the detail. So this is only the recap. So finally, we discuss about the federated identity as well, where we can use the different digital identities, combine them and join them for any one particular user for any particular account. And we can see how we can access them, or give them access, or give them authorization, and these things. So now I hope you understand. This was the a bit important part. That's why we try to discuss it in a great detail. Now we are going to the remaining parts, which is about the computing part and the web services and virtual machines. So first of all, we are just going for the computing concept. This all comes, the web services, the access to the web, to the clouds. That is also come to the computing concepts, and also what type of the services we are providing, that also comes under the computing concept, and also what type of the virtual machines what we are using, how we are using, that comes also under the computing concept. So today we are going to start that one now. So in the computing concept, as we discussed, that there are a couple of the computing concepts. Means it's not only one concept or the single concept. We call the utility concept or utility computing. Utility concept or utility computing, it means that whenever the user is using what type of the services or what type of the utility from the cloud. So the user will be having the authentication or authorization for that particular part. So utility computing is a practice of treating the computing resources like a meter. What it mean by the meter? Like anybody who is using, we are calculating like a meter, and we can charge them accordingly. How much what someone used, we charge them accordingly, like a metering for water and the energy like what we are using. So that's why he is giving the example for the water and electricity metering. In the utility computing, the service providers only charge the user the part and services what we have used. So this is the natural phenomena. So whatever the services we are using, how much MBs or how much bandwidth or how much we are consuming, we are supposed to be charged against that. And in case we are using more, then we are supposed to pay more, and in the same way, vice versa. So this concept is actually easily we can call it pay as you go. Means how much you use, how that much you are supposed to pay. So most of the means cloud service providing models, they are providing very attractive packages, and they are charging us based on the means in two ways. Someone they are charging based on the time, that how much time we are using, and someone they are charging us on the quota of the size, that how much size we are using accordingly. So someone they are means providing us the monthly and yearly and quarterly referral as well, that how much we can pay this much, and then we can have the access up to this one. So if we talk about the Google Cloud, so this is actually called the GPC. So Google Cloud is actually charging the something which is known as the in the form of the credit, and for each credit is actually for $1. So you can see that $25 will be required to have the 25 credits, and then we can start their services. So that also everything means Amazon have this, means different concepts. The Azure has different concept. AWS are the Intel or GPC. So each and everyone has the means different ways and different, but the baseline concept is the same when we talk about the utility computing, but they are entirely having the means different attractive packages for each other. Now, if we just go ahead, so you can see from here the computing concept. It's very simple. So, but again, we are trying to explain it a bit more for your better understanding. So from here, you can see that the computing servers, okay, sorry, the commodity servers in computing concept, because we need actually the servers from where we can get the access for any of the data, and we need those services, whatever the services, whatever the memory, whatever the thing, for everything, each and everything, we need to have the servers so we can use. So that's why, just to make you clear, so you can see from here that commodity servers is the concept of using the general non-specialized server. So for this utility service, we are providing the services. When we are saying we, it means the cloud, or those parties who are handling the cloud. Means maybe it is the Google Cloud, maybe it's Azure, maybe it's Intel, maybe it is the AWS, maybe whatever the cloud. So it means that when we are saying we, so don't confuse yourself. Okay. Now, instead of using the different servers for the different tasks, the same servers are used for all of the tasks. Okay. So what we are doing, that we are using the same servers, because for the utility services, this is very small enough. It is not required a very huge level of services. And when the user are using the services in the utility, they are using very a small parts and small chunks of the services. So for that, we may not keep our all of the servers or all of the clouds or all of the data centers under use. So the commodity servers are lower cost system as well. So these are the lower cost system, and they are offering the different small services to the independent user, and as well as to the organizations as well. It depends on their requirements. So that's what he means, that instead of putting many tasks on one powerful server, the task can be spread over for many less powerful servers. So the basic message is, the primary message is that for this utility services, we may not require the powerful servers. We may not require the powerful, HDA, the zone that what we discussed. I hope that you remember. We may not require a dedicated, what we can call the data center. But because these are the small services, and that we can handle it from the low power servers, and it's easy for us to use. Okay. So now the above, what we can call the above practices, also referred as the scaling out instead of the scaling up. So this is scaling out. These are the concepts. Okay, when we are saying scaling out, so it means these are the, we can say these are the like a byproducts, the small products are means very chunk, small chunks of the products which we can means provide to the customers, and that is the additional services by the cloud for the individuals, and then we are charging them as much they are using, and that can be used by anyone. And for that, we may not require a very highly infrastructure, means heavy duty servers, but we can use this one by using the small servers. And also it is not required that we can dedicate any server, even those are the small servers, but we can use the multiple servers and we can do this job. This is known as the scaling out instead of the scaling up. And that could provide the means use of the community servers for binding their virtualization infrastructure. Now, what is the virtualization infrastructure? This is the most important part, because in the cloud infrastructure, we do this. You remember in lecture number 2 or 3, where I was trying to explain to you that what is the data center, how we sit, and what's the control room. Okay, how the race floors are there, and how the rack are there, and what is the EOR, and what is the DOR, and what is the HDA, and what is the ZDA, and how many different layers we have. You remember we said that this is the core layer and aggregation layer and whatever the layers are, and how we are connecting the whole operation. So at that time, if you remember, I told you that how we control, we don't go physically to the to the service, but we have a control room, and from that room we have the machines, and those machines have the virtual machines. So that's we call them the VM. In the cloud concept, VM is very important. And the virtual machines, they are again, we have the 3 types, but most popular types are the 2 types. Type 1, we call them type 1 and type 2. The type 1 and type 2, they are differentiated from each other. We will discuss them today as well. And the type 3, which is not common, so most of you will not find about the more information about the type 3 wherever you means Google it, wherever you go for the books, wherever you can find out the information. Most of the time you will find out the information that's the type 1 and type 2. But in actual, type 3 is also there, which is known as the hybrid one. That's what we discussed once we reach there. So the virtual machines concept, so we are controlling all of the servers using the VM concept. So VM concept is very important. That is the one which is helping us to control and switching the cloud services, and to handle the clouds, and to administration of the clouds, everything you can say, and anything that is the point of contact with the clouds. Okay, now most of the cloud servers, they are using the commodity services. As you can understand from the name, that the commodity, it means that is the something which is the means small level services, that what we already discussed. So going ahead, that this is the means what we can call the autonomic computing. Okay, so these services, which are the commodity services, they are autonomic, are most easily at an abstract level, which you can understand, means more easily for your better understanding, that these services are means autonomic computing, which are making by the system, where we don't require actually the people, human interaction we don't require. So these things we are normally handling with the help of the machine, with the help of the servers, with the help of the cloud itself. So any services or anything from the commodity, if suppose required to anyone, so they can be able to access that one, and then they are keep charging them as well at the same time. Okay, so that's why we call them the autonomic computing, is make the computing system to manage themselves automatically with the close to zero human interaction. So this is when we say the close to zero, so you can understand it's almost, maybe the human we require some time for the maintenance or something, but actually for operations, it is almost we don't require the people, it is automatically means self-service. The other name we can call it like a self-service. That's what it is means referring to the second point. He's saying that it refers to the self-managing characteristics of the distributed computing resources. So it can be adopted automatically by the machine. It can be assigned, or it can be assigned to anyone from any particular part of the globe, and how many person or how many people they are using. That is very easy. So they can be charged as per their use and whatever it is. So the computing system, this is called the computing self system, and it is very effective and very optimized and self-protecting system is for this that particular chunk or particular part of the community services what we are using in the computing concept. Then virtualization technologies, as you remember, I told you that we are handling hardwares or the softwares or everything in the servers in the data centers that we are handling only with the help of the virtual machines. So if you remember, we just discussed that and we just referred to that particular control room where we have the virtual machines. And virtual machines, they are of type 1 and type 2. We'll discuss it in further detail in the upcoming slides, but I can let you know what's the main difference for the type 1 and type 2. Type 1 is the virtual machine, which means having the operating system on it. On the second one is that is the VM, means it does not have the own operating system, but it has the first has the operating system, and on top of that we have the virtual machines. So I will brief you in these in upcoming slides. So just wait for a couple of minutes. So making this concept is making the machines more autonomous, more automatically, and easy to handle, and no person is required. And these services are available for any individual or any industry people as well. And this is means as you pay, as you go, as you pay. So pay as you go, whatever the concept you can call. Okay, so this is all about the computing services. Now we're coming to the second point. This is about the hardware virtualization. This is actually hardware virtualization is actually the part where we were discussing about the VM, virtual machine. So whenever we talk about the virtual, this means that there is nothing there physically. So you can see from here, hardware virtualization is used to generate the simulated physical system on the top of an actual physical machine. So VM is actually simulated environment. There is no actual physical existing is there, but we can use means in simulated environment and virtual environment, and those virtual machine, that's why we call them as a virtual machine or VM. And with the help of those virtual machines, we handle all of the clouds. That is the means a very basic principle that how we can handle the clouds. In most of the cases, the multiple simulated physical systems are there. Most of the cases, we have so many virtual machines with the one of the data center. So you can notice that we have so many virtual machines through which we can access them, through which we can operate them, through which we can process or execute any task, or through which we can switching or jumping from the one data center to the other data center as well. Means this is the point of connectivity, source of connectivity, that is the VM or virtual machines. So it can increase the usability and efficiency of our systems. So when one VM is not using VM virtual machines, they can be jumped as what I mentioned to you, that it can handle the instances of the different servers. Like suppose with one virtual machine, we can handle the multiple several servers. So we can handle the different instances, and then we can switch them from one server to other server, from one rack to other rack, from one data center to other data center, from one cloud to other cloud. Even they help us to jumping our services from one country geographical location to another country. Now, question is there, why we need to do that? Say, for example, if you remember, I told you in the lecture number 1 and lecture number 2, that say, for example, that you have a cloud center and you are using the cloud services, which is situated in Malaysia, and that data center is almost equivalent to the C5 complete floor or C9 complete floor, which is very huge, and thousands of servers are there. What happens if suppose it's nighttime and the people are switching off their services and they are going for sleep, because this is natural. So automatically those servers which are free, so the virtual machines can send them to the sleep mode, or they can send them to the switch off mode as well. So this is natural that possibly the time will come that now you are from your whole data center, maybe you are using only 10% resources or 20% resources only. So now while you're using from the 1,000 of the machines, only 10% or 20% resources at that particular time, if suppose you wish to keep that data center alive, then it means that you are having a cost for the electricity, for the cooling system, and for other things a lot. So this is not the wise thing. So what we do, then automatically our virtual machines, they can switch or jump that the operations what they are running in the 10% or 20%, maybe in any other geographical location. Probably we have the night, so any means location where that is the daytime. So we call them technically the means sun time. So if it is a sun time, so it can be all of the services will be switched there, and those users who are using the services, they will not be interrupted. They will not be knowing even, because these things can be done in seconds, even less than seconds of the time. So now after that, what happened? You can be able to means switch off your or keep it in the sleep mode, your whole data center, so you can means be able to save your resources. So now I hope you understand it, how much it is increased and why we are saying that it is increasing the utilization for our system. So you can see from here, the next point, what it is saying that when one virtual machine, VM is means the virtual machine, is not using a physical system resources, the resources may be used by another virtual machine. That's what the example I gave to you. So now what happened if suppose that one of the place where means 70% is already in use, 30% is not in use. So from here we can means switch off our means keep it on a sleep mode, and we can switch those services to that particular part. So in non-VM environment, the system resources may be idle most of the time. If this we all, that's what I'm explaining to you. This is possible that we can do with the help of the virtual machine. If it is not the environment in the virtual machine, the physical environment is there, that like what we have in our with our own machines, then in that particular cases, there will be a possible problem that most of the time our resources will be means useless. They are in idle condition, and then the cost will be higher. So then the clouds will be not able to compete, and they will not be able to provide us the services in the same specific rates that what we have. So now we are coming with this one. The virtual machines are being handled with the hypervisors. Okay, hypervisor is a means very important concept through which we can handle the virtual machines. So you can see from here that the means hardware virtualization is implemented through the hypervisor, and hypervisors, they provide us the virtualization capabilities. Okay, so the hypervisors, they are how and what type of in nature they are. It means in the nature, you can Google them, you can find it out. They are in nature in the form of the hardware, and they are in nature in the form of the software as well. So it acts as I will try to means we will try to go if time allows in the next lectures. I will show you that how these operations are means happening for the hypervisor in a simulated environment, so you can understand more accurately that how these things are working actually. So it acts as the intermediary between the physical system and as a so-called host system. So hypervisor is the something which is actually in between the physical system and your virtual machine is running on that. So this is the intermediate level of the concept where we are going to virtualize the system. Different hypervisors require different components to be installed on the host system to provide the virtualization. Mostly, when probably is the hardware-based hypervisor, but we have some of the hypervisors, they are software-based as well. So similarly, different hypervisors provide the different options of the guest operating systems as well. So we can run the operating system on the hypervisors. Hence, we need to ensure the hypervisor chosen support the features needed for the cloud implementation. So we have a multiple different type sort of the hypervisors. So when we are going for that, so we have to be careful what hypervisor we are choosing. If that particular hypervisor is best fit for our case or not. Okay, that's the most important point. So now you can see from here, if I just means take you first to the next slide to the figure from where you can be able to understand it more clearly. So if I just make a mouse pointer, just give me 1 minute to the pointer. So it will be easy for you. So you can see from here that this is the hypervisor one. Okay, this is known as the native, and we also call it the bare metal. And this is the type 2, which is hosted one. So how and what it is. So you can see from here that this is the hypervisor here, and this is the hypervisor here. So in type 2, you can see that this is the means operating system, then the hypervisor, then the host machines, host operating system, and then it is the hardware. So in this way, you can see this is the hardware, and then it is the hypervisor, and then we can run the means operating system. So you can come up from the top to bottom for your better understanding. You can understand it easily. So you can see from here that this is the hardware. On the hardware, we can have directly the hypervisor, and then hypervisor, they can run the different means operating system. This means that we can have the different number of the VMs. You remember we told that we will have the different number of the VM or virtual machines. So now these virtual machines are actually residing on the hypervisor, and mostly we are using the one which is the most powerful, which is known as the type 1. In type 2 and type 1, what's the difference? In type 1 and type 2 is difference is that in this particular hardware, we have in between the host operating system. And on that a host operating system, after that, this hypervisor is coming. And after that, we can have the different instances. So this is the primary or the basic difference between both of them. And the third one is the hybrid one. Okay, but as I mentioned to you that when you go and means look for that, most probably you will find the type 1 hypervisor and type 2 hypervisor. I will try to show you some simulated environment from where you can get the better understanding about that in future. So now going back to the previous slide, what we left. So you can see from here that hypervisors are of the two types. As I mentioned to you that you can find mostly about means the details for the two types. One is the type 1 and the other one is the type 2. The type 1 hypervisor generally sit directly on the top of the hardware. So you can see from here, this is actually means cloud hardware, and then it is means normally sit on that. And then we have the different instances. This is being handled by, we can call VM1, VM2, VM3, and so many. So how many VM we can have? It depends on the hypervisor, what type of hypervisor we are using. Okay, but normally we have multiple. Normally we have multiple, 10, 20, 30, and like that. Okay, we can have the VM. This is, we are talking about the VM, not about hypervisor. And then again, go back. So you can see from here that the type 1 act as their own operating system, allowing them to make the more efficient use of the physical system resources. Own operating system for which? Own operating system for the hypervisor itself. That's why what it means that it is the more powerful and we can handle. So now here in between, there is some other thing as well. Here it is directly. Sorry. So now you can see from here that due to the above reason, the cloud environment built using the type 1 hypervisor. That's what I mentioned to you. The type 1 hypervisor is the most commonly in use. Type 2 hypervisor generally sit on the and other operating system. That's what we notice here. That is the operating system is here. And then we have the hypervisor, and then we have this. So this is how they can work. Sorry, this is how they can work. We can may go back. So you can see from here the hypervisor act as the control system between the host and operating system. So the advantage of the type 2 hypervisor can be installed on a desktop system, not necessary to have the separate system installing a hypervisor. So this is actually, you remember I told you that we have the hypervisor of two types. The one is the hardware type and the other one is the software type. So you can see from here that in type 2 hypervisor, what it's saying, it can be installed on a desktop system. So normally you are installing your virtual machines, okay, VM machines. That is also means then your operating system is that is means helping you, handling you like the means to control the cloud or control the environment. You can access to the cloud. So in that particular case, this is known as the type 2. While the type 1 is mostly commonly used in the data centers, cloud centers, which is in the control rooms. So now I hope that you understand the difference between both of them. Now when we go ahead, so now here is discussing about the hypervisors. We have different means manufacturers and different types of the hypervisors. There are so many, but here we are just discussing the few for your better understanding. And I hope that the type 2 hypervisor, most of you already you use them. Like suppose you are using the VM machine and you are using the different means software-based VM machines, and then you are installing some other softwares. That is also is doable. Or suppose you are going to install the two operating system on your machine. So again, you need the virtual machines. So that is the type 2 hypervisors. So now from here hypervisors, this is the one of the hypervisor which is known as the Xen hypervisor. So XEN Xen hypervisor has the two versions. This has the open source version, and also it has the means commercial version as well. So what's the difference between both of them? This is very pretty simple. The open version, which contain that is not having the same level of the capabilities, which capabilities we can have or we are expecting from the other version. So this is how commercial version offered by the Citrix called the Xen server. So Citrix is what? Citrix is the means same hypervisor that what we are using also while we are trying to access the server of the university from home, and then we are enrolling your attendance and for these things during this COVID situation. So that is also known as the means XEN or Zen. Zen server is the type 1 hypervisor, and it is customized version is the Linux installed on the server hardware. So this is how we have the different operating systems on install them, and then we can control the different instances, and then we can remotely control the machines and the physicals and hardware data center. So you can say that Zen is the RxCN is the first of its type. There are so many, as I mentioned to you, it's not only the one. Now hypervisor from the Microsoft, it has the name like the Hyper-V, Hyper 5, whatever you can call. That is the type 1 hypervisor, and that is installed after the Windows operating system. So we can install on the Windows operating system, we can install a few of them to the Linux operating system, and we can install a few of them on the different operating system as well. So this is the hypervisor. V-based, virtual machine based RVMs are access to the Windows operating system. Because this belongs to Microsoft, so Microsoft owns the Windows. That's why it is pretty sure that it is working with the Windows. But we have the different virtual machines, different hypervisors that we have for the different operating system. So just going ahead to brief you about a few more. So another one, this is the KVM. So you can see from its icon that this is actually for the Linux one. So it has the KVM has the two means further types. One is the vSphere and other one is the KVM. vSphere is very popular one. vSphere is the type 1 hypervisor offered for the VMware, and vSphere is widely used within the organizations to provide a VMS to the private cloud functionality. As I mentioned to you, that is the actually really very popular one and very widely used hypervisor. Then the KVM is actually the kernel-based virtual machines. So you can see that this is the KVM, and this is an open source one in Linux based. Again, Linux based because you can see from its icon very clearly, and it also supports to the wide variety of the operating systems as well. So it can support to the Windows and Linux and other guest operating systems as well. So that's what we mean that this is the most of the popular and common operating system. Now we are coming to the web development technologies. Yeah, that is the another concept, which is the more important concept as well. Like what we discussed about the computing concept, we discussed about the authorization concept. So you can understand that we are trying to discuss the different things which are the actually related or linked with this one, with the cloud. So now we are going to discuss about the that is known as the web services. Now there are so many web services we are using. So we are not going to go in a detail at what web services are, but we are just trying to enlist them at least so we can know that how. Because most of the web service models, they are providing us the access through the web. So it is easy for the users, and it is simple for the users in so many different ways that the user does not require to install or configure any software in most of the cases, and they can easily access to the cloud services. So this is the one of the most important component in the clouds as well. That's why we call the web development technologies. They can help or enable to the clouds that we can access them properly. So in this part, you can see that web applications are accessed via the internet. So whatever the web applications are, we can access them through the internet, and whatever the services we can access through the browsers. Okay, so with the help of the browser, we only require the browser. So we don't require mostly to install or configure any of the software or any of the tool or any of the specific thing which we may require. And then we say, for example, you want access to the Google Drive, you want access to the say, for example, the Dropbox, you want access to the sync, you want to access so many. So for most of them, you don't require anything, but you may have the Explorer browser, and then you can be able to access them. So the web apps are becoming a facto standard for offering the applications. This means that is the primary standard, which is normally they're acceptable by all other cloud through which we can access them. So the browser is the most important part in the cloud environment, And that's why web development technologies are also, because we cannot use the web browser until we are not having the support from the web technologies. That's why we are discussing what type of the web technologies are there. It's very important to consider the web application technologies, those which can help us to access the cloud, or which they can help us to the means accessing the PaaS platform. So I hope that you are aware about the PaaS, IaaS, and everything that what are the cloud environment. So this is how the web part is important for us. Now, what the services are in the web development? It's pretty simple. So we may not go, in detail because you are already aware about that. But at least we just enlist the names so you can be aware about that and what these things are. So you can see that the browser cannot work without HTML. So that is the one and most important part. At the same time, Adobe Flash is really important. HTML5 is really important. Nowadays, these things are truly important. Otherwise, your browser cannot work. Your browser cannot support most of the things. Even if suppose Adobe Flash is not there, you will not be able to have the videos or something other. So these all things are actually essential that can help us to access the cloud services in any of the mode or in any of the model. So this is the primary component as well, and very important as well in the cloud environment. And this is not only the HTML, Adobe, and HTML5, but there are a few more things as well that we can see in the upcoming slides. Like suppose Java, this is what we are using. It's called the Java first because you all are aware about the Java. Probably you are aware about the SOAP as well. The SOAP is actually the simple object access control protocol. Okay, this is we are normally using for the messages and XML. This is the something which is helping us with the help of the XML, and this is also being used for the web services. So we are using the SOAP, HTTP, SMTP, and there are so many different protocols. They are helping us to access the clouds using the web browsers. At the same time, we will have the JavaScript, ASP.NET, PHP, and all of them, PHP and ASP.NET. You know that how we are handling them. There are the client side and there are the serverlet, server side scripting languages as well, and how we are using, why we are using. So these all are the tools which are helping us to access the cloud services using the web browsers. So going ahead, what next? The next is the Ruby, JBoss, and JSON. JSON, I hope that you are aware about that, which is the very fastest through which we can be able to fetch any data. We can fetch any information from the cloud. So these all are the web technologies which are actually enabling our browsers to connect with the cloud. Okay, and we cannot claim that these are the only few that what we mention here, but there are so many other things as well. And these things and this list is growing with time to time. So new things are again coming and they are adding up in this one. So we cannot say it's only the JSON and PHP and ASP and Ruby, but no, there are so many things coming with the time. So anything which is any technology which is helping to the browser so that make it faster and make it efficient, that is actually enabling us to connect with the cloud. So that is the most important part of the cloud as well. So that's why we discussed that as well. So now I hope you understand that why we talk about the web technologies, why we talk about the hypervisors are the virtual machines, and you know what are hypervisors are virtual machines, and you know what is the type 1 and type 2, and you already have the experience for the type 2 and type 3, which is very rare one, which is known as the hybrid type, and also the commodity concept, not commodity but commodity. Okay, the commodity concept and how much services we are using in the computing and authentication, authorization, and these all things which are related to your cloud. So I hope you understand these things more properly. And these things are very simple, but they just only require the proper understanding. So now this is the end of this chapter, and we have a time we can go for the next chapter as well. Because in the next week, which will be the independent learning week, there will be no classes for that particular week, but you will have the different tasks and you can prepare for your midterm exam, and we will have your midterm exam, your test in the week number 9. So we will discuss about that exam as well at the end of the class. But before that, we are ending up here. And before we go to switch to the second chapter, we may go for the attendance first. Okay, so keep your the devices ready as we can go for the attendance. So I will stop sharing this screen and give you the access for the attendance as you can done with the attendance, and then we can start the next chapter, and we will have the some of the part will be done today, and the rest we will see later on. Thank you very much for your attention. So be ready for the devices, and here we go. Okay, so just please allow me to stop the recording from this one because we want to go for attendance.